Okay, so for this video, we are going to continue with the differentiation of product and also the quotient rule. All right, but now we are going to discuss it in application questions. Okay, so again, after you learn all the product rule, quotient rule, or whatsoever, generally the way that you want to apply in the application question, they are still the same like what you learned before. Okay, so like for example 11, they actually want you to find the equation of tangent. All right, so before the equation of tangent, generally what you can see is you are having a equation that can separate it into two brackets. So your first bracket will be x power half or square root x. The second bracket will be ln x. So when you want to do the differentiation for this equation, you need to apply the product rule later. Okay, and then you substitute the value x equals to 1 after you do the differentiation and substitute x equals to 1 into dy dx to get the gradient of tangent. All right. After that, also substitute x equals to 1 into the y and try to get the equation of tangent yourself. Right, so this example to me, I think is quite straightforward. I would just want you to do it on your own. So first step, you need to find out the dy dx. Okay, so your dy dx, the equation will look something like this. Okay, then after that, if you substitute x equals to 1, then you'll get your dy dx equals to 1. Okay, and then you'll get your y equals to 0 if you substitute the x. Substitute. Wait. All right, so substitute x equals to 1, and you'll get dy dx equals to 1, y equals to 0. And after that, if you continue from here, try to form the equation of tangent. So the equation of tangent will be y equals to x minus 1. So this question to me, I think is quite simple. So I would like you to try on your own. Okay, so I already tell you the process already. So make sure that you try out yourself. Okay, so this is what you have for example 11. The first application for differentiation, which is finding out the equation of tangent. All right. Okay, so let's continue to example 12. Okay, so to me, example 12 will likely harder. So I will discuss this with you. Okay, so if you have a look, you will see that, okay, I'm having the curve with this equation, and then they only consider for x greater equals to 0. So it is shown in the figure like this. The stationary points are labeled T1, T2, T3, and so on. So you can see T1, T2, T3, T4, all these are the stationary points. Okay, so first, what they want you to find the x coordinates of T1 and T2, giving the value into 3 decimal places. Okay, so they want you to find out the x coordinate of T1 and T2. So as T1 and T2, they are actually the maximum or minimum point, right? Okay. So first, if you want to find out the maximum or minimum point, of course, you need to do differentiation. So this is what you learned before. So y equals to 10 e negative half x, and then you're having sine 4x. All right, so for me, myself, I will treat the 10 e power negative half x as one bracket, sine 4x is another bracket. So you're having two brackets here. When you want to find out the differentiation, you need to do the product rule. Okay, so first, copy the first bracket, differentiate the second. So when I differentiate the second bracket, I'm having 4 cos 4x. Okay, then plus, now I copy the second bracket, I differentiate first. So when I differentiate the first bracket, I'm having 10 e power negative half x, and after that you you differentiate the power of the e. So when you differentiate the power of the e, you're having negative half. Okay, so if you try to simplify from here, you should be able to get the answer. Okay, maybe I squeeze it a bit. Right, so you should get the answer, which is 40 e negative half x cos 4x and minus 5e negative half x sine 4x. So this is your dy dx. Okay, so after you do the first step dy dx already, then the second step is you need to let dy dx equals to 0. And then if I look at the equation here, right, I realize that I can factorize 5e power negative half x. So if I factorize out the 5e power negative half x, I'll have 8 cos 4x minus sine 4x. Okay, then again, this is one bracket, this is another bracket. So when you let it equals to 0, right, you solve. So 5e negative half x equals to 0, and then 8 cos 4x minus sine 4x equals to 0 as well. Okay, so if you try to solve this one, you can take ln both sides and try to solve, right? Okay, if you want try to take ln both sides, and no matter how, you will get a math error eventually. So you have to ignore this part. There's no answer from this part. Okay, then now we look at this one. If you rephrase everything, then you will have tangent for x, which is equals to 8. All right. So what is your basic angle? So your basic angle. So you need to solve to get the x, right? So you need the basic angle first. Okay, so what is your basic angle? So your basic angle is tangent inverse 8 that you might get a value. Okay, so to get the answer, they want first two answer T1 and also T2. Okay, so they want T1 and also T2. Alright, so that means for x, you need to go through the quadrant to get the first two answer that you want. Okay, so you are looking for tangent positive. Can you see that this is tangent positive? So for tangent positive, the answer is from first quadrant and also the third quadrant. So answer for first quadrant is basic angle. So your basic angle is tangent inverse 8. Then if you want to get that from third quadrant, it will be what? It will be pi plus tangent inverse 8. So this is first quadrant. This is third quadrant. Okay, pi, which is 180 plus basic angle, but we are using pi here. Because again, the trigo or the trigo function, right? If you involve it in differentiation or integration, everything must be in radian. Alright, so after you get an answer for first quadrant, after you get an answer from third quadrant, then you bring the 4 over, become divided. So you have two answers here. So if I'm not mistaken, your first answer for T1, the x coordinate for T1 is 362. The answer for the second, for T2 will be 1.147. They want 3 decimal places, right? So you will see that 362 will be your T1, 1.147 will be your T2. Okay? Alright, so again, you will see that the process is more or less the same, just that now they bring in a lot of things. So first, you need to know how to use the basic product rule, okay, how to use the product rule to find out the differentiation. And from the product rule here, you also need to know how to differentiate the basic function sine for x, how to differentiate e power something. After that, when you want to find out the x coordinate for stationary point, you need to let dy dx equal to 0. So that's something that you learned before. And after that, you need to know when you try to solve this equation equals to 0, right? E power something equals to 0, you won't get answer. You will get a math error. Okay? And now, the last part here, you also need to know how to solve the trigo equation correctly. So you can see that this one particular question, they involve a lot of small details from different chapters. Okay, so for this part, when you're solving, right, you're still using the knowledge that you learned in there, how to solve, how to go through the quadrant and so on. Right? Okay, so these are the two answers that we get for part 1. Okay, then now let's continue to part number 2. Okay, so for part number 2, they said it is that the x coordinate of Tn is greater than 25. find the least possible value of n. Okay, so this is the question that is quite challenging. Okay, so before we start, right, I just want you to have a look here. Just now, the 0.362 is your T1, right? And then 1.147 is T2, correct or not? Okay, all right, so now, what I want you to see now is they are asking for Tn. Okay, they're asking for Tn. So I will want you to try to link your T1, T2 and find out the Tn because you want to know what is your formula for the Tn actually. Okay, all right, so I will want to use the answer here. Okay, so you see what is T1 actually? So your T1 is equals to what? Is equal to 1 over 4, then tangent inverse 8. Okay, or maybe I will write it again into a fraction. Right, so it will become tangent inverse 8 divided by 4. Okay, it is from this equation. Tangent inverse 8 divided by 4. So your T1 is tangent inverse 8 divided by 4. Then if I look at T2. Alright, so for T2, what will happen is you're having pi plus tangent inverse 8 divided by 4. That is your T2, correct or not? Okay, so now can you imagine if I want to find out T3, what is the next formula? Okay, so to find out T3, right, you have to take T1 plus 2 pi. That means it is one round after T1. So when you want to take T1 plus 2 pi, that means you need to add the 2 back here. So this one plus 2 pi divided by 4, then you get the T3. Okay, all right, so now to get the T3, you need to go through one more round for the first answer. So that means you need to plus 360. So 2 pi plus tangent inverse 8 divided by 4. Okay, how about T4? So T4 is what? Is again this answer, the T2 answer plus 2 pi. That means plus one more round. Okay, so pi, 2 pi, you have 3 pi here. So 3 pi plus tangent inverse 8 divided by 4. Okay, so I don't know whether you can see the pattern or not. All right, so let us have a look for the pattern here. When there's T1, there's no pi. When you have T2, there's 1 pi. T3, there's 2 pi. T4, there are 3 pi's in your stack. Then the rest of the thing are the same. Okay, so from here, I hope that you can see a pattern from here. All right, so now if I continue until Tn, can anyone tell me what is the formula for Tn? It will be n minus 1 pi, and then plus tangent inverse 8 divided by 4. Okay, so this is the equation of Tn. So how I write it out, I will just look at the pattern of my step number 1 and try to write it out. So some students will say, I don't know how to compare, and maybe I'm not able to think of this step in the exam. That's normal, okay? So that's why I said you need to try a lot of questions so that you actually have the idea how to solve different type of questions. So this is something extra. Okay, but the technique is not in our syllabus. There's no syllabus saying that you must tell the student how to compare the steps and write out the formula for Tn. So it depends on your knowledge actually. If you try more, then you roughly know how to compare and then you eventually can write out the formula for Tn here. Okay, so again, if I go to the question, what are they talking about? So they're talking about Tn is greater than 25. So that means Tn is more than 25, which means n minus 1 pi plus tangent inverse 8 divided by 4, and it is more than 25. Okay, so if you continue further, you want to get the value of n, right? So the n should be more than 32 point something. And n must be an integer, therefore n should be equals to 33. Okay, so this is one of the questions that I think which is quite challenging because a lot of students, they might not be able to think of this method. Okay, but some students, they will use the arithmetic progression to find the answer, also can. The formula here, the pattern here actually is an arithmetic progression also, like if you can see. Alright, so for me, I just compare. So it depends on you whether you want to try arithmetic progression or you can use the comparison to write out the formula for Tn, up to you. Okay, so no matter how your final answer should be, n equals to 33. Okay, so this is one of the questions that I think is worth for you to try out and also quite challenging. This is one of the passive questions. Okay, so again, make sure that you try to figure out whether you understand or not every single step here. Okay, so that's why I discussed it with you here because it is quite tough. Right. Okay, so let's proceed to the next example. Okay, so example 13. Alright, so for example 13, you are having a curve with this equation. So very obvious, you should use the quotient rule to solve. Okay, so they want to find the x-coordinate of this point. So what point is that? It is a stationary. Okay, so to find the stationary point, generally what you need to do is that you need to do the differentiation first. So y equals to e power 2x divided by x power 3. Okay, so let's find out dy dx first. So this is, to me, it is a quotient of a fraction. So I will use quotient rule. Square the bottom, it becomes x power 6. Copy the bottom, differentiate the top, you have 2e 2x minus, copy the top, differentiate the bottom. So differentiate x power 3, you have 3x squared. Okay, if you try to rephrase it better, then you're having 2x power 3 e2x minus 3x squared e2x over x power 6. Okay, then next, if you want to simplify, you can simplify. But here they didn't ask you to simplify, right? So you can just keep your dy dx like this. Then when you want to find the stationary point, you let dy dx equals to 0. Okay, so when you try to let dy dx equals to 0, your equation, the x power 6, if you bring it up, it is still 0. So your equation will look something like this. Okay, and after that, what can I do is like I can factorize out something from my equation. So I just left 2x minus 3. Okay, so when you try to solve everything here, right? Okay, so when you try to solve everything here, you have x squared equals to 0, e power 2x equals to 0, 2x minus 3 equals to 0. Then you have x equals to 0. This one, if you try to solve it, you can solve and you ignore. And then this one, you have x equals to 3 over 2. Okay, then if I substitute for this answer, you have x equals to 0 and x equals to 3 over 2, right? But after I double check, I will ignore the value x equals to 0 also. Why do I ignore this answer? Okay, so the reason is what? The reason is you try to substitute the x equals to 0 into your original equation, you will get a math error. Therefore, there's no solution also. That's why you have to ignore also x equals to 0. The only possible value for the x at the stationary point is x equals to 3 over 2. Okay, so I hope that you have an idea on this. Okay, then next, what they want. So now they want you to determine. Okay, so wait for a while, the file. Okay, so they want you to determine whether this point is a minimum or a minimum point. Okay, so now they want you to decide. Okay, so again, I hope that you still remember that in AS level, we actually learn one new method, right? To determine whether is it maximum or minimum. Okay, so the old method that you learned before is d2y dx2. Okay, so now you can see if you want to find out d2y dx2 for this equation, it will become very complicated. For me, I don't wish to try. If you want, you can try. Okay, so if you want to continue to differentiate for this one, you have to apply the quotient rule again, and you have to double apply very tough product rule on top also, when you want to apply the quotient rule again. So for me, this equation will be very, very, very hard for me to do the differentiation for second time. So that's why the table method that we learned before is important now. So what is the table method? You need to draw the table. Okay, so I'm having the dy dx here. What's my stationary point? X equals to 3 over 2, right? So I will write x equals to 3 over 2. This one is x smaller than 3 over 2. And this is x larger than 3 over 2. Okay, so when x equals to 3 over 2, generally you'll get a 0. For x smaller than 3 over 2, so 3 over 2 is 1.5. So I will suggest you to use 1.4. You substitute 1.4 into your dy dx. Okay, the step no need to write out. Just substitute the 1.4 into your dy dx. Press calculator carefully, and you will get a negative value. So I put it as negative. Okay, so maybe I put here lah. Use x equals to 1.4, and you substitute it here. Okay, and then for this part, you use what? You use x equals to 1.6, and you substitute into dy dx also. And then just press the calculator button to show the detail how you get the value. You will get a value which is positive. Okay, so again, negative. Dy dx negative means that your tangent has negative gradient. Therefore, your tangent will look something like this, straight line, but it is with negative gradient. So 0 means your tangent is a horizontal line. Positive gradient means your gradient will look something like this. Your equation of tangent will look something like this. So when you join them together, you will see a minimum point here, and therefore you can say that it is a minimum point. Alright, so I believe that from part onwards, every time when they ask you to prove the maximum or minimum point, right, to determine whether it's a maximum or minimum point, it's quite hard for you to apply the differentiation for second time already. Alright, so the other alternative is you can use this table method that we learned in AS level before to determine, okay, whether is it a maximum or whether is it a minimum. Okay, so this is some of the application questions that involve the product rule and also the quotient rule. Alright, so again, after this video, please go and try all the partial questions, if possible, that involve this part one, this concept one. Okay, because I can see that some of the questions from the A-level exam question, exam question paper is quite tough actually. Some are quite simple, but there are quite a number of them which is quite challenging. So it will be good if, let's say, you can try all, you try to figure out which part you don't understand. Okay, so we'll stop here for this video. And then next video, we are going to learn another new technique. We call it as implicit differentiation. All right, so we'll cover all this in the next one.